Today we are having with us one of the most eminent personality, Engineer Ramprakash ji. He is Chief Engineer at Himachal Pradesh Electricity Board, and he has worked. He has worked as a worked in Bhutan in one of our very important hydro project also, and he is a best person to explain that how we can have the smart energy as far as smart cities are concerned. So welcome you, sir. Uh, Ramprakaji,
Yes, yes,
am I audible?
yes, yes. Yes.
Okay,
Thank you very
so
much.
I would like to welcome you, sir, and
Okay.
thank you for sparing your valuable time. Now, I would like to request our head of the department, Dr. Sanjay Sharma, to kindly say a few words.
Okay. Thank you, Amit. And first of all, I would like to extend a very warm welcome to Ramprakash ji,
Thank you,
who
sir.
has agreed to deliver a talk on smart energy concepts. And I think we have given a very little notice, one small time only, as notice given yesterday only regarding
Yes,
deliver the talk on this particular topic. And we are thankful to you because you accepted our invitation. And in fact, this particular program is on smart city and sustainability, sponsored by DST. And the participants are from Tamil Nadu, Punjab, Haryana, this Chandigarh, and like that, at the level of executive engineers and assistant engineers. And some of the academicians, they have also joined from some universities. And we have been basically discussing different topics like smart water management and what are the say missions under this particular, and smart energy is one of the uh, basically main mission in that concept. Basically, we need to understand, okay, how we can make our say energy distribution, our energy system smart, so that can have maximum, give maximum benefit, 24-hour supply without any interruption supply, and then at the same time managing energy saving also. So I think these concepts will be discussed by our expert. So, sir, I again welcome you, and request you to kindly share your expertise with our participants. So thank you very much.
thank you, sir. Thank you very much. And good afternoon to all participants. So I am obliged, sir. I got this opportunity uh, to deliver my experience, because the smart city is the basic um, hot topic to be talked today. And Government of India has identified about 100 smart cities to be developed. And in Himachal Pradesh also there are two cities, Shimla and Dharamsala. They are being developed as smart cities through uh, some special purpose vehicles are working there on. So in those smart cities, this portion of smart energy, as such, it is not being executed by that special purpose vehicle, but from our own side, HPSCB is working on that through different projects. So we are going to install smart meters, then smart grid. The proposal is also there, but it is being taken independent to that smart city project. The smart city is being handled by special purpose vehicles. So when we talk of this smart, it is inherent that ICT, information and communication technology, is involved. It is being involved, and as an initiative in smart city vision, the initiative is to improve this city smartness, and it are focused on the following lines: energy production from renewable sources, to reduce energy cost, CO2 emissions, and to satisfy the increasing energy demand in urban areas, and building efficiency to reduce energy demand and consumptions, local transport qualities and willingness to reduce pollutions, and driving from transport in cities. So when we talk of this sustainability, energy comes into play. So sustainability is very much linked with the energy. So, sir, I have a small presentation, so I will go through that, and I'll welcome any further inquiries, or questions by the participants. So,
Sir, you can minimize the screen and open the presentation.
it is visible.
Yes, sir, if you could do the slideshow so that it will be visible on the full screen.
Is it visible? You can go to slideshow from there. Yeah.
Yes, sir, it is visible, sir.
So when we talk of smart energy system is a cost-effective, sustainable, secure energy system in which renewable energy production, infrastructure, and consumptions are integrated and coordinated through energy services, active users, and enabling technologies. Because we have the electrical infrastructure, uh, and it is passive electrical infrastructure, you can say. Make it smart, we will have to introduce some intelligence devices, and the ICT plays the major role in that. So we talk of smart city, why this concept of smart city has come. It is a crucial space where economic and cultural development has happened, and with the dimension of cities, they are posing dramatic problems for their management, pollutions, overpopulation, and scarcity of natural resources, to difficulty in public and private services. As per one of the estimate, by 2050, about 70% population will be in cities. At present in India, 29% population is residing in cities. So these are the challenges we prompted for introducing the concept of smart cities. Basic concept of smart city or land is involved, then people, infrastructure, and government. The land is the territory on which the city is built, the geographic area on which the city has its own boundaries, and people, citizen living in the city, who also works or studies in the city, or comes to visit the city or to enjoy some other culture or leisure facilities. Then there is the infrastructure, is all the material technological facilities supporting the urban life, such as public and private buildings, streets, transport, production sites, and so on. And the government is the public powers to govern the city and public administration agency to manage and supply public services. So, smart city dimension, it is smart mobility, smart environment, smart people, smart living, smart governance, and smart economy. The main aspects of smart cities are effectiveness, the capacity of a city to supply effective public and private services, then environment considerations, to prevent environment degradation, use green energy, save energies, and then is the innovations, use all the new and available technologies to improve the quality of its core components, to deliver better services and to reduce its environmental impact. So therefore, technology is the central aspect of smarter cities used in the service of smart initiative for the quality of life in the city. We talk of energy. Energy comprises of everything. It is inclusion of more sectors: electricity, heating, cooling, industry, building, and transportation. But I will be talking only about the electricity, smart electricity. So my topic will be focused on the smart grid, basically. So smart electricity is better management energy at generation, transmission, distribution, and customer points. HPSC will being distribution company have role in the management energy better at distribution level. HPSC will initiated various projects for effective management of energy to increase efficiency and quality. Component in the distribution automation is the one of the part of this smart projects. Smart grid is the uh, component of smart city. But until unless your electricity is smart, your city cannot be smart. So this is the major activity uh, in a smart city project. So it involves electrical substation automation, then distribution automation, geographical information system, then is outage management system, then is advanced metering infrastructure, then is the peak load management. So these all activities are focused for conservation of energies, better management of energies, better utilization of energies. We talk of the electrical substation automations. It includes controlling of substation remotely from central location through SCADA protocol, then the real-time monitoring of various parameters, voltage, current, power, power factor, real-time monitoring of status of various components, isolators, breakers, and fault passage indicators, sectionalizers, auto reclosers, etc. Then the remotely open and close of the feeders. So this requires the numerical layers to control the various parameter of feeders, and is the remote terminal inlets to provide the control of substation to remote center through SCADA. Through SCADA, the substation is controlled from remote location, which is a central point. Through remote control center, number of substations are controlled and operated. Distribution automation is used for transient fault, permanent fault, monitoring of transformer loading. This is basically to ensure that the consumer gets the minimum interruption. So through these automations, the system is provided that if one side of the system goes faulty, the other side system is automatically reconnected and supply is restored. So there is minimum interruption to the consumers. So various electrical components are being used for isolation of faulty sections. So we use the auto reclosers, we use the sectionalizers. So they sense the fault temporary faults and immediately isolate that faulty position. And again, they give another try. If the fault is cleared, which happens in case of transient fault, the system is restored. So without manual intervention, this happens automatically, and it is being monitored at the central console center. In case the fault is permanent, that system gets locked and it sectionalizes, it isolates the entire area, and then whenever our crew they will rectify the system, then the system will be restored again through remote centers. So it is also monitoring the distribution transformers and loading, phase loading, wire level, farm temperatures, so that through transformer monitoring, the damage can be avoided and they can be effectively used. So to get this smart city project implemented, we also need to implement uh, to get the GIS survey. So the electrical network is mapped digitally through GIS. It is a continuous exercise. Electrical components, substations, field devices, electric line, poles, transformers, number are mapped with the detailed coordinates. And it is updated regularly. This data is being updated. GIS also help in geographical representation of electrical network, including electrical components. It help in energy audit, outage management, fault location identification, and distribution automation. So through GIS, we will be able to know which area is faulty, which area is without power, and uh, which area has restored, which has not restored. This is being facilitated. Then there is a outage management system that I talked about. That in case something goes wrong with one transformer, the supply is switched on to the other. and from one circuit it is switched on to the other, and this happens automatically. And consumers are also informed when there is failure of the supply. SMS goes to the consumers that the failure has occurred, and also indicated the tentative time for restoration is also given, indicated in the message. So OMS has feature to inform the consumer plants. We can also intimate them about the plant shutdown through SMS or emails. OMS is increased to quality of power and minimize the outage durations. Then is the major component in this that is regarding this EMI. This comprises of smart meters, MDAS, meter data acquisition system, then head-end system, and meter data management. So smart meters, they are like the other meter also, but they have the intelligence built therein. They are monitoring this time of use, tariff is being implemented. Remotely, they can be connected, disconnected, and real-time data is coming, which is also available to the consumers also. They can view it. On demand, we can read it. So prepaid functionality is also there. Uh, Consumer can switch over to prepaid mode, or at any time he can move to postpaid mode. Then load profile data is also available. So we can see the load profile of each consumers also, and for entire feeder also. Then billing data is available on which we are using the sending the bills to the consumers. And in case some fraudulent activity is going on in the field by the consumers, that data is also available with us. So as I told earlier that in Shimla and Dharamsala, the two identified smart cities, uh, we have proposed to install about 1.52 lakh smart meters. So, so far, because this technology is not so mature, because there is a issue of interoperability also, because for communication, we have RF communication and GPRS communications. So each manufacturers have their own specific design. So its compatibility with the various network service provider, that is one of the big issue at this stage. So once we have selected some network provider as on today, tomorrow it will be very difficult to change over to other network providers. So this is the biggest constraint as on today. So still government of India is working on this, how to resolve this issue of interoperability, because meter manufacturer, one there are different meter manufacturer, Landis and Gas, L&T, Secure Meters, and Genus, who are manufacturing these smart meters. So their compatibility with various networks service providers, that is the big challenge. And in case utility go for one make of manufacturer of meters, he may not be in a position to change that meter with other manufacturer. So these are the big issues. That's why this smart meter project is not uh, taking so much pace in the country. Selectively, people are going. In Indore, I think they have gone for 50,000 and plus 2 lakh. There are two projects there. 2.5 lakhs. Similarly, in Jaipur also, two projects are going on, but meters are also in the range of 2 to 2.5 lakhs. Then in J&K also, and in Tamil Nadu also, there is one project. But still, there are certain reservations. Or moreover, uh, this installation of smart meter is a very highly capital intensive project, because a smart meter costs us rupees 5,000 plus, whereas the conventional meter as on today it is 500 and 600 rupees. So from usability point of view, from benefit point of view, this is more beneficial to the utility rather than the consumers. consumer has only the benefit that he can view his consumptions, he can monitor his consumption, or he can control if there is such provision in his wiring. So these projects are not so overtaking. So these are the major reasons. So these are the main components of this AMI head-end system and meter data acquisition system. The data comes to this system, then it goes to MDM, which collects this. Through MDM, we generates different reports, tempering report, energy audit report, billing report, load profile report, etc. So those reports can be configured in MDM. Then there's a peak load management because based on the load available with us, uh, we can utilize it for load curtailment. It can be used for load casting also. And from better load casting, we use our energy efficiently and utilize the system also effectively. So HPSCL has taken certain initiative for this. We have implemented smart grid project at Kalam, and the PGCL was the consultant in this. The operational acceptance of this project has been completed in January 2019. Because this was a pilot project, so we have installed 1,335 number of meters. And as I told, that proposal for implement smart in Simla Dharamsala is still in progress. And also, this smart grid is being proposed to be implemented in 13 cities in the state with about 3 lakh consumers. And the entire infrastructure, distribution infrastructure is covered there. So this proposal, we are getting it financed from World Bank. So at Kalam, these are the components which we have discussed: AMI, with data management, and distribution transformer monitoring units, voltage management, peak load management, SCADA, and substation automation system, demand side management, demand response management. So as I told that there are 1335 number of smart meters, 914 single phase and 133 three phase, 50 LTCT, DT meters, 9 LTCT consumer meters, 2002 HCCT meters, and 24 feeder meters. So there are load profile, billing data, and temper alerts. So this is the screen which we get. I think this is very small font, so it may not be visible, but it gives the active energy, apparent energy, reactive energy, and then active demand, sorry, and apparent demands and average power factors. So this data is continuously coming to us in the interval of half an hour. Similarly, is the billing data. It gives the billing data, what was the kWh consumptions, kBh consumptions, and the total kW, total kVA. So based on this data, the consumers are being served the energy bills. Then is the temporal alerts. This shows the tempers, so various tempers, city bypass, or in this data there is only city bypass, but it shows all the temper, city short, and voltage failure, etc. All tempers are coming. So through monitoring this, based on this data, we can penalize the consumer who is found guilty of misusing the power or indulging in theft of power. So this data is continuously monitored to take the actions against the defaulters. So HPC is generating bills from smart data available at the control centers. These smart meters can be connected and disconnected remotely, but this can be done only for single phase meters, for the city meters and for registering energy through cities and PTs. So this is not possible because this connection is not possible at this stage. So this can be done only for single phase meters. So on demand read of smart meters, we can read the smart meter as per our requirement. If we want this to analyze some of the meters, we suspect some consumer is doing some fraudulent activities, we can read his meter on demand. Or in case he want to go for disconnection, so we can read it and have the final reading to issue him final bill. So in case of this meter disconnection connection, this request type, this it comes like this: connect, then disconnect, then this response is completed. So we get this status, so we know which meter has been disconnected and which has been connected. And this similarly for on demand, so this also comes instant data we are requesting, and this says that this stands completed, this request stands completed. So this is a interactive software. Complete information is available. And then is the meter communication status. How much meters? So here this is showing that non-communicating is 466 and communicating is 618 and DTR 6 and 13. So this figure is changing because in GPRS there is some inherent problem in GPRS. At a time we are not able to read more than 70 centimeters. So in the next street, that 70% also some of the go missing, but from the balance 30%, some will be get ready. So this is the problem in GPRS communications. So now the trend is to go for RF communications. The cities in Indore and Delhi also, Jaipur also, they have gone for this RF communication, and as per their experience, they are able to read 99% meters by the end of the month. The purpose of billing. Then is DTMU, distribution transformer monitoring unit, measures wire temperature, palm temperature, and oil level. And this DTMU screen looks like this. Shows the loading per phase loading, and this shows the deviations. Unbalance also is coming, and this is the feeders. It's showing the feeders, and we have installed the various equipments and auto closures and sexualizers, and it is showing the status of these DTRs also in this diagram. So it is coming live through communications. Then is OTM outage management system. It is able to predict, detect, and confirm an outage. Then prediction logic by 30% of smart, then outage instance will be created. Once the incident reported, it can be assigned to crew members, and they will go and they will attend this, and accordingly they will convey the message, and accordingly it will be updated in the system. So incident updation is there, and this OMS screen it looks like this. So this is all through geographical mapping. So it shows the areas and those show the here the some incident has occurred. This is showing I. This needs to be removed. So this message goes to the crew, and he will attend it, then send the SMS back, and the status is accordingly changed. So these are the all screens pertaining to this OMS. This is the SADI. We are monitoring for the quality of power and the quality and reliability of powers. Then is the peak load management, and peak load management we have this forecast of power, and forecast of power is for a 1 week period, and it can be for a monthly. So based on this, we can plan sale of power in exchange or somewhere else, or utilize it somewhere else. So this is also helping us in effective utilization of our energy, and effective utilization of our equipments, especially in peak hours. Then we talk of this SCADA system, we have 28 feeders of 132 kV substations, which has been put on SCADA, and parameters, voltage, current, load, power factor frequencies are being monitored. These auto reclosers, externalizers, TTMUs, fault passage indicators are also mapped. Parameter of auto reclosers are also this are being monitored, and outer close section can be disconnected through SCADA, and all the connection or disconnection of field devices, we have the facility available from our control room, and we can connect and disconnect them. This SCADA screen looks like this. So it is a single line diagram of the substation. So all the parameters, voltage, current, power flow, everything on every feeder. And it is also showing whether the breaker is on, breaker is off. So everything is available side. So though this is in respect of the feeders, we have taken some sample feeders, 10 feeders. On the feeders, order closures, sectionizer, DTS is showing the status of every equipment in our control centers. So this SCADA system already, like everybody might be knowing, and throughout India, SLDCs, state load sector is working. There is a complete SCADA system for 66 kV and above available, but now this is being under this smart grid project. All the 33 kV substation and below, they are being covered for this SCADA system. The SCADA system. So this is remote metering, central visualizations, and remote operations. These are the measure. And 132, currently we are not doing at 132 kV substation because this is connected to the central SIDC. So we are not operating it under this smart grid project. So thank you very much. So this is the small presentation. If anybody, any participant has any question, they are welcome. I would like to clarify, but I will do like to stress that as on date, there are certain apprehension of discoms, as there is a lot of pressure by government of India also to switch over to smart meters and with prepaid facilities. They have linked it with the various disbursement of loans, various reforms. But because we will have to replace the entire existing meters, which are costing crores of rupees, and their disposal is also one of the big issues. In HPCV, we have around 25 lakh meters, 25 lakh consumers. So if we want to replace 25 lakh meters, we need about 1500 crores rupees to install these smart meters and this AMI infrastructure. And the meters which will be removed, they are also costing. They will be costing around 2 to 300 crores. So their disposal is also one of the big issues. Thank you very much. If anybody has any question, I'm ready to answer.
Dear participants, if you are having any query, you are most welcome. Anybody, any participant want to ask anything as far as smart energy development is concerned, so you are most welcome.
Hello. Hello.
Hanji sir.
Hello. Can you hear me, sir?
Yes, yes.
Good afternoon, sir.
Good afternoon.
It was a very nice presentation, and I want to know, sir, what is the total impact of this smart metering and smart energy system in the T&D losses, which lot of electricity boards and lot of distribution companies are facing these days?
Okay.
What actually impact will it bring to these losses?
Actually, the project जो हमने अभी implement किया है smart grid, it was a pilot project only. So, well, this project was installed not from the perspective of reducing losses. So it was a proof of technology that this is existing. So whenever we will install the rest of the state, then definitely when we will getting the online information of energy, everything will be monitored. So they will be definitely have impact on T&D losses because the consumer will not be so easily able to indulge in malpractices. So, but major issue is the investment cost of these smart meters because the investment is so huge that we will not be able to. It's because in HPSCB the total T&D loss is around 12%. So to reduce it from 12% to down below, it's a very gigantic task you can say because this is the minimum T&D loss we have achieved. So reduce it further, it requires crores of investment. But by changing the meters only, because in HPSC we are happy that this commercial loss and theft is not so rampant. It may be around 0.5%, it may be 0.6%. So I don't think we will be able to draw any significant benefits from these smart meters as on date. So that's why other states are also going very slow in implementing. They are very precarious. We make the huge investment, but outcome may may not be so visual. That is one of the issue in this. So every state is very cautious to implement these smart meters. So until unless this is being done, so I think the smart city concept will not be fulfilled. This is the one of the major component in the smart city. But still, Government of India is trying and recently they have come with standard bidding document for this EMI smart meters. So a lot of steps are going on, but still the technology is not mature. So there are certain problems because the manufacturer are also very limited, and their RF module is their own. It is not interoperable. So there are a number of issues. Still, government is going taking a lot of efforts in this.
Okay, any other participant here? Madan ji, Sharma ji, और कोई question
Thank
है?
you, sir.
So any other participant? Anybody else? Participants from Tamil Nadu, are you getting it or not? Lakshman ji, Lakshmanan, sir, are you getting it or not?
Getting, sir.
Getting. Okay. So do you have any query related to your field because you are working in the field and especially the program is for field engineer. If you want to know anything about it, you can ask.
Okay, sir. In our field, we are does not use any smart energy to us. Only solar power, only we are using in greenhouse using, sir. So there is no more research to us.
Sir, in this smart city project, this integration of renewable energy, this includes solar power also. This is also the one of the component.
Okay, sir.
So, Government of India is declaring solar city if total renewable power of around 25 megawatt is injected in that project.
Okay, sir.
In this smart city concept, the major focus is on energy, green energy. So everything is hovering around that energy. So this is the essential component. So most of the people are going for this rooftop installations in Himachal also. It is around 14 megawatt. Still people are installing the solar power projects.
Okay, sir. Thank you.
Anybody else? We are having our professors also in this. So Kaleem ji, Dr. Syed Kaleem, Dr. Kaleem. Anybody from Chandigarh? Because they are implementing it. I think some electrical engineers are also there with us.
Yes, sir. Yes. Chandigarh also, I think, project is going on. Smart city project, smart metering project also.
Jasjeet Singh ji, I think you are from the electrical field. So I think, sir, there is no more queries. So I would like to thank you for sparing your valuable time, sir, and
Welcome.
interacting with our participants. And I hope that our participants got something about from that what are the initiatives Himachal Pradesh Electricity Board is taking as far as smart cities are concerned. So I hope that participant can interact with you further also. I will give all the participant your email ID and your phone number, and
Yes.
if they are having further queries, so they can always call you, and they can always email you about that query. So thank you so much for thank you so much, sir, for
Welcome.
sparing your time. Thank you so much, sir. Thank you.
Welcome. Thank you very much.